Hello students, welcome to this lecture. Here we are going to study about some CBSE pattern questions on surface area and volume chapter. So we have gone through the theory of this chapter of surface areas and volumes of some solid figures. Now we are going to see the questions which are generally asked in CBSE board exams. So the first question, which is of 2 marks, it says that a cubical block of side 7 cm is surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. So there is a cubical block, it is a cube basically. So we draw a cube. Cube is a solid figure whose all of its edges have equal length, A and A. And here on the top of it we surmount it by a hemisphere. So first they are asking what is the maximum dimension radius of the hemisphere. So the hemisphere will take this as the diameter, and this is also a diameter, and this will be a hemisphere like this. This is over this box, over this block. So this is having dimension 7 centimeter. So this hemisphere will have radius equal to 3.5 centimeter, that is half of 7 centimeter, and over this we can surmount a hemisphere of the maximum dimension. Now if we want to find the surface area of the solid so obtained, so first of all let us find the surface area of this cube. So surface area of cube will be equal to 6a square, that is 6a square is actually 6 into 7 square. Now what is the surface area of this hemisphere? So curved surface area of this hemisphere is equal to 2 pi r square, that is 2 pi, and r is 3.5, so 3.5 square. Now there is an important thing, if you surmount it by a hemisphere, the area which is the base of the hemisphere, that will cover this cube. So that area will have to be subtracted from this surface area of cube. So what is that area? The base area of that hemisphere, that is equal to pi r square, that is pi into 3.5 square. So if we want to find the required area, we will say that the answer should be, surface area required should be the surface area of the cube 6 into 7 square minus surface area of the base area of the hemisphere, which is occupied by this hemisphere, that is pi into 3.5 square, and then we will add the curved surface area of the hemisphere plus 2 pi into 3.5 square. So this will become 6 into 7 square, and this will become pi into 3.5 square, which will become equal to 6 into 7 square plus pi is 22 upon 7 and 3.5 is 7 upon 2. So 7 upon 2 into 7 upon 2. This 7 will cancel. This will become 11, and we can take 7 as common. So 6 into 7 is 42. Here we take 7, so 11 by 2 is 5.5. Now this can be written as 42 plus 5.5 is 47.5. 7 into 47.5. Just calculate this and get the answer. This is the answer which we have. So this is the surface area of the solid figure. There is a hemisphere here. You can understand it like this. There is a hemisphere over here. So the surface area of this hemisphere plus the open area of the block. Let us come to the next question. That question is also of 2 marks. From 1 to 4 all the questions are of 2 marks. So the next question is, a medicine capsule, this is in the shape of a cylinder with 2 hemispheres stuck to each of its end. So there is a hemisphere here and there is hemisphere here, these 2 ends. The length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter. So radius is 2.5 millimeter. So we can say this is 2.5, this is 5 millimeter, and similarly this part is having also radius equal to 2.5 millimeter. So both of them is 2.5. So can we say that the height of this cylinder, length of this cylinder is 14 minus 2.5 minus 2.5, that will be 9. So this is the height. The length of the entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter. Find its surface area. So if we want to find the surface area, first we find the curved surface area of the cylindrical part. So, what will be the curved surface area of cylindrical part? That is actually 2 pi RH. So, 2 pi R is 2.5 into H is 9. And what is the curved surface area of this hemisphere? 2 pi R square, and that hemisphere, that is also 2 pi R square. So, curved surface area of hemisphere. So, that will be equal to 2 pi R square, that is 2.5 square. So, the total area which we need is actually 2 pi, let us take as common, 2.5 is also common, here there is 9, here there is 2.5. So, this is 11.5. So, 2 pi, pi is 22 by 7 into 2.5 into 11.5. Now, 3.5 into 2 is 7, 3.5 3.5 into 3 if we will take, that is 10.5, not 11.5. So, we keep it like this only, and we can calculate this value, just multiply 222 this and get this value, that will be the answer for this question. So, this is the total area of the capsule which we have. Let us move on to the next question. I hope you will do the calculation part, simple calculation, you do not have to use calculator. Third question, a wooden article was made by scooping out a hemisphere from each end of a solid cylinder as shown in figure. If the height of the cylinder is 10 centimeter, so this height of the cylinder is 10 centimeter, and further its base is of radius 3.5 centimeter. So, its radius is 3.5 centimeter. Find the total surface area of the article. So, article has the surface area around this cylinder and this hemispherical scoop which is done over it and under it. So, if we take the surface area of the cylinder, that is 2 pi RH. So, 2 pi, radius is 3.5 into H, that is 10 centimeter. This is the cylindrical part. We will add this this ball shaped figure over here having some surface area, that is 2 pi R square. So, 2 pi R square, and if you observe, this area is also having same area, that is also 2 pi R square. So, we can say this becomes 4 pi R square, both will add up like this. So, this will be equal to 2 pi common, 3.5 is also common, 10 plus 2 into 3.5, 7. This is what we will get here. 2 pi is 22 by 7. So, 2 into 22 by 7 into 3.5 into 17. Now, here you can cancel, 3.5 into 2 is 7, 2 into 2 cancel. So, 22 into 17, just calculate 22 into 17 centimeter square. This will be the area required for you students. So, we have to understand that how the figure is coming out. Now, let us see the fourth question, the last question of 2 marks. A gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be formed in 45 gulab jamun, each shaped like a cylinder with 2 hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. Okay. So, figure is given like this. So, first let us find the volume of 1 gulab jamun. Volume of 1 gulab jamun, since it is a shape of a cylinder with 2 hemispherical ends. So, similar figure as we saw in the case of capsule. So, the cylindrical part has length 5 centimeter. So, it is said each shaped like a cylinder with 2 hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. So, length is the length of the whole gulab jamun. So, length of the whole gulab jamun is given, that is 5 centimeter, and the radius, if diameter is 2.8, then radius is 1.4. So, this part is 1.4, this part is 1.4, both is 1.4, and the total is 5. So, let us subtract from 5 1.4 into 2, that is 2.8, that will become 2.2. So, this is 2.2 centimeter. So, if we take the volume here of the gulab jamun, the cylindrical part has the volume pi r square h, pi r square, that is 1.4 square into h, that will become into 2.2, pi r square into h. If we add it to the volume of the hemisphere, 2 hemispheres, so twice of volume of a hemisphere is 2 by 3 pi r cube. So, pi and radius is 1.4. So 1.4 cube. Now this is the volume of one gulab jamun. If it is given that there are 45 gulab jamuns, what total volume of the gulab jamun is 45 into this value. Let us calculate this value even. So let us take pi common and let us even write pi as 22 by 7 into 1.4 into 1.4 into 2.2 plus 2 into 2 by 3, pi is 22 by 7 into 1.4 into 1.4 into 1.4. So this will become 7, 0.2 is 1.4 and here 7, 0.2 is 1.4. What else we can take common? 22 we can take common, 0.2 we can take common and 1.4 we can take common. What will remain inside? 2.2 here, and what will remain here? 22 is common, 0.2 is common and 1.4 is common. So 1.4 into 4 by 3. So we have to calculate this. 1.4 into 4 is going to be 5.6 and 2.2 into 3 is going to be 6.6. So 6.6 is here and 5.6 is here, that will add up to 12.2. Okay students, so this is 12.2 by 3. So 22 into 0.2 into 1.4 into 12.2 upon 3. So we can do further calculation. What we have to do is find the volume of the 45 gulab jamuns. That will be 45 into 22 into 0.2 into 1.4 into 12.2 divided by 3. So 39 is 45. This is what we have the volume of the gulab jamun as. But what we need the volume of the syrup. Find approximately how much syrup would be found. So 30% of its volume is syrup. So what we will say, volume of syrup is equal to 30% of this volume. So 30 by 100 into this value, 9 into 22 into, so I am writing as V, total V, which is present there. So this is the answer for volume of the syrup. So as you can see, everything is in centimeter over here. So the volume will also be in centimeter cube. So this is the volume of the syrup, students. Now let us come to the next question. So different type of figures will come across to you. Cylinder and hemisphere we have seen. We may see cone also. So 4 marks question is the fifth question. A solid consists of a right circular cone. So this is a question of cone of height 120 centimeter and radius 60 centimeter. Standing on a hemisphere of radius 60 centimeter is placed upright in a right circular cylinder. So first there is a cone with a hemisphere at the bottom and a cone at the top, and it is given that it's having the height of the cone as 120 centimeter and radius equal to 60 centimeter. So this part is the radius, which is equal to 60 centimeter. And the hemisphere is also having radius 60 centimeter. So this is the figure we have, and this has to be inserted in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and its height is 180. So the cylinder with the water is also having radius 60 centimeter. This is 60 centimeter its radius, and its height is also 180 centimeter. That is actually sum of these two heights. So here there are water, and what we have done, we have taken this cone and inserted into this cylinder till the bottom of this cone comes here. So since height is this, it will occupy the full volume except the water, which will remain somewhere here, somewhere here. If you put this over here, this is a cone, this is the hemispherical bottom. So the volume of water will be here, here, here and here. This will remain, and they are saying find the volume of water left. So this volume. So what you have to do, students, you have to find the volume of this cylinder and subtract from that the volume of this particular solid, which is cone plus hemisphere. That is the volume which will left, and that is the volume of water. So let us calculate. Volume of the solid is equal to the volume of the cone. Volume of the cone we all know 1 by 3 pi r square h. R is 60, so 60 square, and height of the cone is 120 plus volume of this hemisphere. So 2 by 3 pi r cube, which is 60 cube. So I am not doing the calculation part. You can do this. This does not require any intelligence here, just calculation. And volume of this cylinder. So volume of this cylinder is equal to pi r square h. So this is pi the radius is 60, so 60 square into height, that is 180. Now what we have to do, we have to subtract this from here. So the required volume of water is equal to volume of cylinder, that is pi 60 square into 180. Pi we can take common, 60 square can also be taken as common. So here it is 180 minus this thing. So pi 60 square, it is 123, that is 40, minus 40, and this here will be pi into 60 square, so 40 here again. 60 into 2 is 120 by 3, 40. So you can say pi into 60 square into 100, and this is again in centimeter, everything is in centimeter, so centimeter cube. This is the volume of water which will remain in that particular vessel, cylindrical vessel, after that solid is inserted to it till the bottom touches the bottom of the solid. Now let us come to the next question. That question is also of 4 marks. Sixth question. How many silver coins 1.75 centimeter in diameter and of thickness 2 millimeter must be melted to form a cuboid of dimensions 5.5 centimeter into 10 centimeter into 3.5 centimeter? So here student, the coin is a type of cylinder, though it is very small in height, very less height, which is called its thickness, but it is a cylinder. That cylinder is having this as the diameter and this as its thickness, or we can say height. So volume of one cylinder is actually the volume of the material used in casting it. So the volume of one particular coin Vc is equal to pi r square h, that is the formula for volume of cylinder. Pi r, r is 2 millimeter is its thickness and 1.75 centimeter is diameter. So radius is half of it. So 1.75 divided by 2 whole square, this is pi r square, into h, that is 2 millimeter height. So we change it into centimeter by dividing by 10. So 2 by 10 centimeter cube will be the volume of one particular coin. Now this is melted to form a cuboid. So volume of cuboid is equal to L into B into H, 5.5 into 10 into 3.5. So this is 5.5 into 10 into 3.5. So how many coins do we need? Number of coins will be equal to total volume of the cuboid 5.5 into 10 into 3.5 divided by volume of one coin, that is pi 1.75 by 2, that is 1.75 square, and here it is 4, this 2 will go in the numerator, into 2 by 10. So this is 2 and this is 10 again. This is the value which you have to find out. Let us see, we can find it out. 1.75 is written as 1.75 into 1.75 again. So if we take 3.5, so this 3.5 into 0.5 is 1.75. As you can see, 5, 5, 25, 2 remaining, and 5, 6, 17. And 1.75, here again what we can do, pi can be written as 22 and here we can write 7. So this 7 we can divide 1.75 again. So this is point, and 7 to 14 and 7, 5, 35, 0.25. This is what we will get. Now further we want to calculate 5.5 and 22 is 4 times. 5, 4, 20, 2 carry, 5, 4, 20, 22. So this we get. Now 10, 5 in 0.5 into 4 is actually 2. This is 2 and this 2 will make this as 5. And this 2 will also make this as 5. So let us see what do we get finally. We do get is equal to 5 into 4 into 5. Let us write it like this. Upon, here nothing remains, here only 0.25 is there. So what we can do, we can take decimal and we can take again 0. So it is 0.05. We can call it as 0.05. So 0.05 and 5, this will become 100. So this will become 400. So how many coins do we need? We need 400 coins. So 400 coins are needed in order to make the cuboid of the given dimension when each coin has this given dimension. Let us see one more question, 7th question. A cylindrical bucket 32 centimeter high and with radius of base 18 centimeter. So there is a cylindrical bucket and its height is also given to us. Height is given 32 centimeter and with radius given as 18 centimeter. Is filled with sand. So this is filled with sand. This bucket is emptied on the ground and a conical heap of sand is formed. Okay, so now this same volume of sand makes a conical heap. If the height of the conical heap is 24 centimeter, find the radius and slant height of the heap. So it is given that height of this is 24 centimeter. So what is the radius and the slant height? So volume has to be same sand is here, same sand comes here. So volume here is pi r square into h. This is equal to volume of the cone 1 by 3 pi r square, r we don't know, h is 24. So here pi will cancel of course and 3 8 is 24. So this is r square is equal to 18 into 32 upon 8. Now 8 4 is 32. So square root when we will take, we will get 118 and 1 2. So radius is 36 centimeter. So the radius which we get as answer is 36 centimeter. This is one answer. Another is finding the slant height. So what will be the slant height? Of course slant height is going to be root over L square plus H square plus R square. 24 square plus 36 square. So what we can do? 24 can be written as 4 into 8. 3 into 8. So 3 square into 8 square and 36 is 9 into 4. So 9 square into 4 square. We can take one thing common 3 and 4 after from the square root. So here it becomes 2 square as we have taken 3 square into 4 square outside plus 4 square has gone outside 3 square. So this is 3 square. So this is 12 and 4 plus 9 is 13. So root over 13. This is the slant height of this cone. So this is how we can attempt these questions. Now let us come to the 8th question, which is now of 6 marks. And this question says a fez, the cap used by the Turks. So this is a cap called fez used by the Turks, is shaped like the frustum of a cone. See this figure. If its radius on the open side, of course this side is open side where we wear this cap, is 10 centimeter. Radius at the upper base is 4 centimeter. Here radius is 4 and its slant height is 15 centimeter. Find the area of material used for making it. So area is basically the curved surface area and the area of the top. Bottom is already open. So what is the area we are making is curved surface area, which is actually pi r1 plus r2 into L as we remember, plus pi r2 square top area. So if we see r1 and r2 are given as 10 centimeter radius and another is 4 centimeter. So 10 plus 4 and its slant height is 15 plus pi r2 square, that is the smaller radius 4, that is 4 centimeter. So 4 square. This will become pi into 14 into 15 and let us take pi common also, plus 4 square is 16. So we write it as pi. 15 into 14 is going to be 210 and plus 16 is going to be 226 students. So we can write it like this, and further if we want we can do further calculations. So this is how we can write the area of the material used to make the hat, this particular cap. Now this is also a 6 mark question. It says an oil funnel, this is the oil funnel, this is open from the top and bottom, then only oil can flow, made of tin sheet, consists of a 10 centimeter long cylindrical portion attached to a frustum of a cone. If the total height is 22 centimeter, diameter of the cylindrical portion, this is 8 centimeter and diameter of the top of the funnel is 18 centimeter. Find the area of the sheet required to make the funnel. So what do we need? We need the curved surface area of this frustum plus curved surface area of this cylinder, that is the funnel. So let us find the area needed. So curved surface area of this frustum is going to be pi r1 plus r2. So this is radius 9 centimeter, half of 18. This is a radius 4 centimeter, half of 8. So 9 plus 4 into L, that is the slant height. Can we get the slant height? This is 22, this is 10. So this height is 12. Okay. and this difference is actually, this whole radius is 9 and this radius is 4. So, this difference is 5 centimeter. I hope you understand, 9 minus 4 will be 5. So, if we want to find the slant height, this is root over 12 square plus 5 square. 12 square is 144, 5 square is 25. So, this will come out to be 13 finally. So, slant height is 13 plus curved surface area of this cylinder, which is 2 pi RH, 2 pi, radius for this is 4 centimeter and height for this is 10 centimeter. So, into 10. So, let us take pi common, 9 plus 4 is 13 square here, plus pi is common. So, 8 into 10 is 80. We can write pi 169 plus 80. Now, 169 plus 80 is going to be 249. We can further calculate it, or we can write the answer as it is also. So, this is the area of the tin sheet which we need to make this particular shape. Let us take the 10th question, last question of 6 marks. In one fortnight of a given month, there was a rainfall of 10 centimeter in a river valley. If the area of the valley is 7280 kilometer square, show that the total rainfall was approximately equivalent to the addition to the normal water of 3 rivers, each 1072 kilometer long, 75 meter wide and 3 meter deep. So, what you have to show here, that the volume of water that came from the rainfall was actually 10 centimeter in height. So, we take it by 10 by 100, that is in meter now, and 7280 kilometer square is the area. So, 7280, and let us change kilometer into meter. So, we will multiply by 10 to the power 6. So, the whole volume will be in meter cube. So, this is 10 by 100 meter height and 7280 into 10 to the power 6 meter square area. So, this becomes the volume of water. They are saying that this volume should be equal to the volume which is from 3 rivers. So, let us take 3 into, the river has the length 1072 kilometers. So, we will write it 1072 into 100 meters into 1000 meters, of course, 75 meter wide and 3 meter deep. So, they are saying that this value and this value should be equal. Let us calculate. This 10 and 10 will cancel, there it will become 110 will cancel from here. This is 728 into 10 to the power 6 meter cube. Let us calculate this also. So, here we find out 75 into 3 is 225 and 225 into 3 is 675. So, 675 into 1072, this is what we get here, into 1000, that is 10 to the power 3. So, let us make it 10 to the power 6 and place 2 decimal here and 1 decimal let us say here. So, this is 10 to the power 6 meter cube. Now, let us multiply 10.72 with 67.5. So, 67.5 into 10.72 we have to calculate. Let us do this calculation. 5 to 10, 1 carry, 7 to 14, 15, 1 carry, 6 to 12, 13. 7 is 7, 5, 35, 3, 7, 7, 49 and 3, 52, 5, 7, 6, 42 and 5, 47. 0 is here. So, 0, 0, 0 will come here and 675 will come here. So, this is 0, this is 10, 1 carry. So, this is 6, this is 7 plus 1, 8, 5, 13, 1 carry, 8, 4, 12, 1 carry, 7. So, 1, 2, 3, 1, 2, 3 decimal. So, this comes out is 723.6 into 10 to the power 6 meter cube. So, we can say, yeah, that the volume of water is approximately, as they are saying, that they are approximately equal. So, we can say, yeah, this value and this value is approximately equal. So, the volume is approximately same. So, this is how we can approach these questions of surface area and volume, students. Study the theory hard and then attempt these questions. Thank you.